Whenever you buy a product from a modern corporate chain, roughly 87% of that money immediately leaves your community. It pays for out-of-state marketing, legal teams, and shareholder dividends, draining local wealth in an economic vacuum. To understand how this extraction became the default, we have to look back to the late 19th century and John D. Rockefeller. Standard Oil constructed an infrastructure of pipelines, refineries, and distribution centers that made petroleum the mandatory lifeblood of global civilization. Decentralized alternatives were a direct threat to this monopoly. In 1900, Rudolf Diesel demonstrated his new engine, which originally ran on locally pressed peanut oil. A few years later, Henry Ford designed the original Model T as a flex fuel vehicle. It could run on gasoline or ethanol fermented from corn and hemp. He envisioned farmers growing their own fuel. That vision of distributed energy abundance was quickly erased. The modern economy is a deliberately engineered system designed to enforce total dependency on centralized petroleum inputs. In 1913, the Rockefeller Foundation was established and began funding what would become known as the Green Revolution. This exported petroleum dependency directly into global agriculture. Traditional, self-sustaining farming methods were systematically replaced. The new standard required massive fields of single crops, which could only survive with constant inputs of synthetic, natural gas-derived fertilizers. These monocrops created a chain reaction of dependency. They needed petroleum-based pesticides to survive insects, and massive diesel-powered harvesters to process the yields. Because the industrial system relies on constant purchasing, any biological technology that is self-sustaining, unpatentable, and localized is treated as a threat to that control. Enter the Moringa tree. This fast-growing plant acts as a biological multi-tool, capable of addressing energy, water, and food crises with zero external inputs. Its seeds are 40% oil by weight. That oil burns clean and runs a standard diesel generator without any chemical refinement or modification. If you drop crushed moringa seeds into contaminated water, the proteins bind to dangerous bacteria, like E. coli and cholera. Within 30 minutes, the particulate matter clumps together and sinks, leaving the water purified. The second piece of biological hardware is the neem tree. Documented in Indian Ayurvedic texts as early as 2000 BCE, neem provides a complex defense mechanism for local agriculture. The tree produces azadirachtin. When insects consume it, the compound disrupts their reproductive cycle. It acts as a highly effective pesticide, completely free of industrial toxicity. Together, these two biological trees provide an open-source replacement for industrial diesel, multi-billion-dollar water treatment infrastructure, and toxic agricultural chemicals. For protein production, the 2,400-year-old Chinese polyculture pond acts as a self-replicating, self-managing protein factory. It starts at the surface. Waterfowl, like ducks, provide a constant stream of natural nitrogen fertilizer directly into the water, triggering a bloom of microscopic algae. That algae is consumed by zooplankton. The plankton feeds small fish, and those small fish feed the larger, harvestable species near the bottom. To prevent toxic algae blooms, aquatic edge plants like cattails and floating duckweed pull excess nitrogen into their root systems. Because every organism's waste is another's food source, this ecosystem requires zero mechanical filtration and commercial feed. A single 1,000-square-foot pond produces nearly double the protein yield of a quarter-acre industrial cattle pasture. By stacking biological functions, this regenerative engine produces more nutrition with a fraction of the space and labor required by industrial meat systems. We can integrate the polyculture pond, the moringa, and the neem tree to serve a 10-household cell. This setup is known as a microgrange. These systems feed each other. Nutrient-dense wastewater is siphoned off from the fish pond to irrigate and fertilize the adjacent neem and moringa growths. In return, surplus moringa leaves are processed into high-protein supplemental fish feed, while neem extracts protect the entire property from pests. All output is distributed through a circular logistics protocol. Goods move in deposit-return glass jars or compostable mycelium packaging, eliminating the cost of plastic waste management. By linking these specific biological systems, A community severs its reliance on extractive, long-distance supply chains. This creates a localized economic model called Commoner Capitalism. Its focus is the sticky dollar, keeping money circulating locally instead of being drained away. This chart shows the difference in wealth retention. While the corporate vacuum extracts 87% of local wealth, the micrograin grill retains 85% of trade value right inside the community. This abundance supports a one-year buffer mandate. By storing a year's supply of these locally produced hyper-fresh essentials, households create a significant shield against global supply chain shocks. Quality control in this localized market is enforced through surety bonds. If standards drop, the bond is forfeited, letting immediate financial consequences and social reputation regulate the market. Economic freedom and biological sovereignty grow from these closed-loop ecosystems, which have the potential to render multi-billion-dollar monopolies entirely obsolete.